Hello again, math students. Today we are going to be working with square roots, which is the reverse of squaring something. So if you would please take out your orange paper that you have with that square and square root chart. We're not going to deal with the bottom part of it today because that's going to be for tomorrow or the next lesson with cubes and cube roots, but we're going to fill this in. Now, I'm going to go pretty quickly on this, so feel free to pause it if you need to, but also know that the completed chart is in Schoology, so you can just look at that if you want to go through these and get them done on your own. In a typical year, we do time tests on this, so I would be asking you to memorize these and be ready to do them very quickly, and we practice it enough that it would be very quickly. I don't think that that's going to be an easy option this year, so I don't know that we're going to do a time test on this. But these are numbers that I would expect you to know. So 1 squared is just equal to 1. So that means then that the square root of 1, so we're going to take that answer and we're going to put it right there. Square root of 1 is just 1. All right, so the 1s are all just 1s, right? 2 squared is 4, so the square root of 4 is 2. And again, if I go too fast, pause it. 3 squared is 9, so the square root of 9 is 3. Remember that square root sign is called a radical. That's something that's going to get used a lot in this chapter. 4 squared is 16, so the square root of 16 is 4. 5 squared is 25, the square root of 25 is 5. You can see that these numbers are just reversing order. 36 for 6 squared, so then the square root of 36 is going to be 6. 7 squared is 49, the square root of 49 is 7. 8 squared is 64, the square root of 64 is 8. 9 squared is 81, so the square root of 81 is 9. 10 squared is 100, so the square root of 100 is 10. 11 squared is 121, so the square root of 121 is 11. 12 squared is 144, so the square root of 144 is 12. Those are the 12 numbers that I asked you to know when you did your quizzes on Wednesday. So if you need to practice these and then redo the quizzes, if you didn't get it perfect, go ahead and do that. 13 squared is 169, so the square root of 169 is 13. Now for 14, we just flip the two numbers at the end. It's 196. So the square root of 196 is 14. 15 squared is 225. So the square root of 225 is 15. After that, most of these, not all of them because 25 is in here, most of these are just multiples of other numbers that we already have. So for instance, 20 squared, 2 squared is 4, and since I have a 0 here, but I'm squaring it, there'll be 2 of those. So that's going to be 400. So the square root of 400 is 20. 25 squared is going to be 625. And the square root of 625 is then obviously going to be 25. Now, after that, all the rest of these are just multiples of numbers that we have up here. So 30 squared, 3 squared is 9, and then we would have 2 zeros. So the square root of 900 is going to be 30. This is going to be 1600. 50 squared is going to be 2500. Okay, and then we should be able to complete the rest of these. So 60 squared is going to be 3600. 4900. 6400. And 8100, or 8100. Now for 100 squared, 1 times 1 is going to be 1, and I've got 2 zeros already, and when I square it, that's going to double that, so I'll have 4 zeros, 10,000. So then the square root of 10,000 is going to be 100. This chart is going to be really helpful today if you are not as confident with some of those numbers, especially some of these bigger ones that you may not have been aware of those patterns. So you're going to want to keep that handy today when you're doing your work. Taking a look at this, think about how we found the area of a square. The area of a square is just the side squared. Well, if I know that the area of this square is 121, then that means that I should be looking at the square root of 121, which would be 11. And we know that 11 times 11 is 121. Remember, the area is square feet. If I'm looking for a missing side, that would just be regular feet then. Now, if I say that the square root, or the area of this square is 81, the square root of 81 would give me that this side would be 9, this would be yards, and so would the bottom. Now, these next two, we don't have those on our chart. They're not numbers that we had memorized. You can absolutely just take the square root of those numbers and, sorry about the bell. You can just take the square root of those numbers on your calculator if you know how to do that, or you can kind of narrow it down. So I knew that 15 squared was 225, and 20 squared is 400, and this number is in between there. So it's between 15 and 20, and it ends with a 4. So I have to think about which numbers could multiply and end with a 4. Like 16 times 16, that's going to end with a 6, because 6 times 6 is 36. 17 times 17 is going to end with a 9, because it's a 49. However, this would be 18, and you can double check me, but 18 times 18 does give me 324. So then again, you can see that this next number is a little bit bigger for the area and still under 400. So it's less than 20, but bigger than 18. This is going to be 19. And again, you can absolutely just use a calculator to do that, but you can also kind of use some of those skills that you have. We just did a bunch of these, right? So the area of this is going to be 225. So the square root of 225, that's going to be 15 miles on each side. Then this one's a little tricky. 289 as just a regular number, 289. That is a perfect square. The square root of 289 is 17. If I have 2.89, when we were figuring out the big chart, when we had the zeros and we squared it, we said we would double the number of zeros. If we're going the other way around, if we're taking square root, it's going to cut the number of decimal places or the number of zeros in half. So if this has 2 decimal places, when I get my answer, when I take my square root, there will only be 1 decimal place. And I said for 289, this was going to be 17. So this is going to be 1.7 inches on a side. Now, feel free to check that. 1.7 squared should give me, and I'm just double checking on my calculator, yep, 289. Fractions, no big deal, especially if they give me numbers like this that are really nice. The area of this square is 4/9, so I would just have to take the square root of that. Well, take the square root of the top and the square root of the bottom, right? The square root of 4 is going to give me 2, and the square root of 9 is going to give me 3. Now, kind of a ridiculous measurement. We would absolutely not see that very often. 2/3 of a foot, that'd be 8 inches. That'd be much easier to work with, but whatever. If I give you the area of a circle, we know that the formula for the area of a circle is pi times the radius squared. Now, take a look at this. This is, here's my pi, times the radius squared. Well, what number squared gives me 36? That's going to be 6 inches. This is an area of pi, or let's say 1 pi. So pi r squared, the 1 is really equal to r squared. Well, that means that the radius is 1 yard. This is just an easy matching, right? 1600, if I take the square root of that, the square root of just 16 is 4. So the square root of 1600, cut the number of zeros in half, that's going to be 40. That's letter D. The square root of 400, again, the square root of 4 is 2. Cut the number of zeros in half, so that'll be 20. Sorry for the bell again. Square root of 144 is just going to be 12, which is A, and the square root of 36 is just 6, letter C. When we talk about square roots, a lot of times we are only worried about the positive answers, especially at the beginning. But there are times when we get more than one answer. So here now we actually have the vocabulary parts that I kind of mentioned already. The square root sign, this symbol, it's actually called a radical sign. You're going to use that a lot in Algebra 2 for sure. The number that's inside that square root sign, that's called the radicand. So it's the number that you're taking the square root of, okay? What we have to be careful about here is that when I'm finding the square root of a number, like 49 for instance, 49 is 7 times 7. Easy. When we say the square root of 49, we just typically think of just positive 7. However, negative 7 times negative 7 is also positive 49. They both work. So I need both answers. And you're going to see this down here, but I can write this. Instead of writing 7 and negative 7, I could write the 7 and put a plus or minus sign in front of it. And that's all we say is plus or minus 7. That means positive 7 or negative 7. So if I'm talking about the square root of 16, normal, just positive square root is 4. The negative square root is negative 4. So when we want both square roots, we'd have positive and negative. Usually, if they just give you something like this, they just want the positive answer. When they sneak a negative right in front, they only want the negative answer. And when they say, let's get both, or if they put that sign in front of the radical, then they want you to get both also. So finding square roots, again, this should be super easy and fast, right? The square root of 25 is going to be, didn't like me there. 5 times 5 is 25, so the square root of 25 is 5. I don't even think that we need to do these because you guys all know those. Again, when we get some fractions, some people freak out a little bit, but please don't. This is telling me I want a negative answer. The square root of 9 is 3. The square root of 16 is 4, so it's just negative 3/4. There's no sign in front of letter E, which means I just want the positive answer. Now, the square root of 4 is 2, and the square root of 36 is 6. That can simplify. That should be 1/3. However, I want you to look at this problem again. What if I simplified, still inside the radical? What if I just said, 4 over 36, I can simplify that. That's 1/9. What's the square root of 1? 1. What's the square root of 9? 3. Either way works. For letter F, again, the negative out in front means that I want just the negative answer. If this didn't have a decimal, if this decimal was just not there, the square root of 225 would be 15. Because that decimal is there. When we have big numbers or small numbers, the number of zeros get cut in half, the number of decimals get cut in half. So since I had 2 decimals here, I'll have 1 number after the decimal in my answer. On this one also, we see the plus or minus. We know that's going to be there. Again, if that decimal wasn't there, our answer would just be 12. Square root of 144 is 12. 2 numbers after the decimal, that means I'll have 1 number after the decimal in my answer. When we are looking, again, for 2 square roots, the square root of 36 could be 6 or negative 6. And if you wanted to write that as plus or minus 6, I am perfectly fine with that. Square root of 100, 10 or negative 10. Square root of 121, 11 or negative 11. When I'm giving you that sign out in front now for number 4, the negative square root of 1, that just means negative 1. Number 5, I'll have the plus or minus sign in front. The square root of 4 is 2. Square root of 25 is 5. Plus or minus 2/5. 12.25, that's not, obviously it's got decimal, so it's not going to be on our chart. But even 1,225 is not a number on our chart. The square root of 1225 is 35. So when I get this answer, I'm going to have to cut the number of decimals in half. So it'll be 3.5. And no sign out in front, so it's just going to be just that positive answer. Now, I do want to mention one thing. These 2 things that I've got here, that versus that, are very different for square roots. This one is fine. We're all happy right there. The opposite, or the negative square root of 49 would be negative 7. That's easy. If you try to type in this one in your calculator will not like you. It's going to say that there's an error because we cannot take the square root of a negative number. Because remember, when we're taking a square root, we're undoing a square, which means I multiplied something times itself. If I multiply a positive times a positive, I get a positive. If I multiply a negative times a negative, I get a positive. There's no way to multiply a number times itself and get a negative. That just doesn't work. There isn't an answer for that. These last ones are where we're actually just doing some evaluating. When I have this 5 smushed right up next to that square root sign, that just means 5 times that. And we know that the square root of 36 is 6, so this is really 5 times 6 plus 7. Well, that's 30 plus 7 is just 37. For B, we're going to keep the 1/4 because it's not in a square root. The square root of 18 over 2, 18 and 2 are not perfect squares. However, 18 over 2 is just 9. So that's really just the square root of 9. I didn't do anything with the square root yet. All I did was simplify this fraction in here to make it into a positive 9, which is really 3. And 3 plus a half is just going to be 3.5. And for letter C, when I have this, I know that some people are like, oh, yay, the square root of 81 is 9. And then they square it and they get right back to 81, right? Because squares and square roots undo each other. So in this case, I wouldn't even bother doing the square root. The square right here and the square root sign are going to undo each other, which gives me 81. 81 minus 5 is going to be 76. Today, you're going to have a worksheet. It's finding square roots. It's a lot of evaluating. Use your chart. Make sure that you check with the key in Schoology, and then there's going to be a short learning check in Schoology when you're done. If you need any help, let me know.